Start recording. Hi, so this week's lesson will be on piecewise functions.
So a piecewise function is a function that can be defined as a function that behaves differently based on the x or the input value. So it is written like this. It has f of x, the function equals, and it has this brace looking thing, and x squared. If x is less than 2, then the function is x squared. If x is equal to 2, then f of x equals 6. And if x is greater than 2 but less than or equal to 6, then f of x equals 10 minus x. So these are the three requirements for the function. So you have to gauge and size up where x, your input value, falls here. So if it's less than 2, then then x squared would be the function, and so on. And yeah, this is just a continuation of the previous slide. We can see that when x is less than 2, the function of f of x will be x squared. When x is exactly 2, f of x will be 6. So that'll just be a point where x equals 2. That point will be x comma 6. And then when x is greater than 2 but less than equal to 6, it will give the linear line 10 minus x. So f of x will be 10 minus x when x is greater than 2 but less than or equal to 6.
For example, if we have like the value x equals 4, our f of x value would be equal to 6 because we can just plug in 4 to this. If our value is 0, then f of x is also 0 because 0 squared is also 0.
And here are some other piecewise functions, so we can just spend a little time to figure out which each function wants, what each function is telling it to do. So a characteristic, if you look at a function, and an immediate way to know that this is a piecewise function is if it has this brace sign, you pretty much know it's a piecewise function. But here, h of x, when x is less than -2, when x is any value less than -2, it could be like negative like 100, the h of x would be x plus 3. And then when x is when -2 is less than or equal to x is less than 1, then h of x will be h squared. And if x is equal to or greater than 1, then f of x or h of x will be negative x plus 2. Yeah, so if x is like 5, then h of x would be negative 5 plus 2, which is negative 3. And if we look at this example to the right, we can see f of x equals negative x if x is less than 0. So if x is any value less than 0, then f of x will be negative x. And then if x is 0, then f of x will be 0. So that point will be on the origin. So when x equals 0, y will be 0, and that point will be 0, 0. And then if x is greater than 0, then f of x will be x.
You guys notice that the equation on the right is actually the function on the right is actually absolute value function. So if x is less than 0, the f of x value makes it negative that, so double negative makes it positive. So this ensures all f of x values are positive, which is just basically the absolute value function.
Yeah.
So now we can talk about graphing piecewise functions. So we have the function if x is less than -1, then the function is negative x plus 1, and if x is greater than or equal to -1, then the function is 2x. So first we graph the lines like normal. So you would just graph negative x plus 1 and 2x normally. and then you would just cut off the parts that do not fit the interval specified. So for the first line, you would cut off anything that is greater than or equal to -1. And for the second line, so 2x, you would cut off anything that is less than -1.
Let's go ahead and try an example graphing this piecewise function. So we are given the equation, we are given the function x plus 2 if x is less than 0, 2x plus 5 if 0 is less than or equal, if x is greater than or equal to and less than and equal to 2, and then negative x plus 1 if x is greater than 2. Please do not forget the intervals because that's what makes it a piecewise function. You can go ahead and try this a little bit by yourself before we move on. Okay, so hopefully you have at least an idea of what the graph should look like. So we're going to go ahead and show the answer now. So this is what your graph should look like. It should, you have x plus 2, or again, the original graph of x plus 2 is graphed here, and then it stops at 0. And when you have a something that's just like the alligator mouth, nothing with the underline on the sign, you want to make sure that it stays an open circle because that means it's up to that value, but it doesn't include that value. So at 2x plus 5, you'll notice that it has the less than equal to and greater than equal to sign. And that means you want to make sure that those are closed circles because those are part of this 2x plus 5, not x plus 2 or negative x plus 1. So hopefully your graph looks something like this. Just make sure you're aware of the signs because that's what makes a difference between having an x plus 2 that can change how your graph will look.
Okay, so let's have some special piecewise functions. So yeah, like I said earlier, we actually had a piecewise function that was split into 3, but this is essentially the same function, right? Below 0, where x is less than 0, the f of x would be negative x, which flips it and makes it positive. And from 0 onwards, including 0, the value is just itself. So if it's just 0, then it's 0, 1, it's 1, so on, just like a linear function. And now we have a special function called the floor function. So it has infinite number of pieces. So this floor function is kind of just one way you think about it is that just remove all the decimal spaces. So if it's anything between 0 and 1, not including 1, then it goes back down to 0. If it's between 1 and 2, not including 2, then it also go back down to 1. So yeah, just it kind of looks like a some people call it like a staircase function. Kind of looks like a staircase. Yeah, anyways, that's it for the functions today. I'm gonna stop sharing.